Hello everyone, welcome to the channel. Imagine having this image with some coins on it, and I was counting how many coins there are in it. As a human, we can visually count the coins one by one to get the result. By counting them, we would conclude that there are 9 coins on the image. But I have another question. How would a computer detect and count the coins? Nowadays, there are many tools that we can use to do this, but one easy solution could be to get a simple AI model or try it in a straightforward way by building a simple Python program to count the coins for us. You might say, okay, this image has 9 coins, no need to develop a program to count them. However, I have more images to show you. Take a look at these images. Like the first one, you can easily count them and come to the conclusion that there are 10 coins. What about this one? Like the others, it is easy to count and the number is 6. Let's increase the challenge. How about this image or this one? You can sit down and count them, but it would take you some time and you would probably make some errors. So what is the number of coins in these images? Lucky you. For this challenge in this video, we will build a program to count the number of coins for us in these types of image using Python and OpenCV. Without further ado, let's build this program. Let's start by creating our main file, which will have our Python script, and then let's bring our images. Each image has the number of coins attached to name, as you can see it there. First of all, we will need to import the package that we are going to use, including the OpenCV package. First, if we are going to detect coins, we need a function to detect the coins, in which we will pass the image path. Also, we need something to know the error in terms of percentage regarding the true value and the estimated value from our predict coin function, and this is the way we are going to calculate it. And since we have the image inside a folder, we can build a dictionary with all the information from the image itself inside the folder. Let's add validation to run this script. In the implementation of the detective coins function, we need a number of coins variable to store the number of coins. We need to read our image regarding the path. We also need to apply a grayscale filter on our image. And then also I'm going to apply a blur effect in the image to help us get more pictures from the image. Also, I'm going to apply an adaptive threshold to adapt for each image, so it can give us really good results. Okay, and then also to detect the circles, the coin circles, I'm going to use the OpenCV function, root circles function. Let me just pass the arguments here. I'm just validating if we have circles there, and also I'm rounding the values to integer. There I'm getting the number of coins based on the length of the circles in the position 0. Also, I'm just connecting the component states in order to show the image and the centroids. I'm going to receive them as parameters if I want to show the image or if I want to show the centroids. Also, to show the images, also to show the centroids, I will just have to run through the centroids to the centroid values and then show it to the user. The centroids are basically the circle positions, or the coin circle positions in the image. And also I need to show the image if I want to show the image, but if I'm going to show the image, I'm going to draw circles hitting the coins that the OpenCV or the function above did find. And after that, I will return the number of coins. That's the function that we already created with the image with 6 coins. Let me bring my my terminal. Let's test it. Okay. Okay, it's saying 3 coins. Okay, something must have gone wrong. Let me just check. And okay, let's change the parameters on the hood circles. Let's change the parameter 2 to 30 instead of 50. Okay, and then okay, it's working now. It's showing 6 coins, and let's test for 10 coins, and let's see, it's working just fine too. Okay, sounds good. Okay, okay. Let's test to show the images. Okay, we can see the images. On the images that we have the circles, the red circles draw inside in the coins border. And let's see the centroids. Okay, we have 10 centroids or 10 coins positioned inside the image. Okay, that looks good for me. And then we can proceed. Now let's build the image lists. Okay, we will start with an empty array, and then we will get the current position, and then we will join the position with the folder path that we are passing with the images. And then for each file that we encounter on the image folder, we will search for the number of coins using regex code, which the number of coins is alongside with the image name, and then we will get it. And then we need to check if the image is is in an image format. I'm using GPG, JPG, but you can use another format image if you want. And afterwards, we will need to append a dictionary with the image information inside the image list, which I'm appending the image, the true coins number, and also I'm appending the path. And then afterwards we need to return our image information list. Then we can test the function that we already built for building the image list. Let's see how does it. Okay, it looks okay for me, and then let's work with that. I'm going to use Python Args parser library to receive arguments while I'm executing the Python code. Hitting these arguments, I will receive the folder path, the image folder path, which is a required argument. And then also I want also to receive if the user wants to show the images from the coins images. And then also I think I would put the user to choose if he wants to show the image centroids. So let me add that. I will show the image centroids, and then that's all from the args parser that I will show that I will allow the user to choose. Then we need to get the args and parse them, and then let's test it. For me, let's test. Okay, it will say that we need to pass them. Let's pass the images. Okay, it looks so it works. It works. And then let's pass the show images, and then it also works. Okay, since we have everything done, now let's organize things. And in order to do that, I will create a new function called main, and then in this main function we will build the image list with the build image list function. Also, we need the total number of images. We need the total relative error, which we will initiate it alongside with the square error, and then we will increment them. Also, we need to run through all the images. I'm running through them, getting the index, and then I will use the detect coins function to detect the number of coins in each image. We will pass the path, and then the args to show if it's to show the images or not, or if it's to show the centroids or not. And then also for the relative error, we have the function that we implemented back there, and then we need just to pass the true value and then the estimated value from the detect coins. And also we need to increment the total relative error, passing the relative error and then the square error. And then After that, in order to calculate the average relative error, we just need to calculate the total relative error by the image number, and then the average square error, the total square error by the average number. And we need to show this information to the console. I'm just making it pretty to show to the user. Okay, almost done. Okay, there I'm passing in the formatted string the 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 2 points dot 2f to just add me to decimal case, and I'm adding this print here just to make it more beautiful on the console. If there's anything else, now everything is implemented, and let's test things. Okay, for all the images, okay, we can see here that the centroids are perfectly designed in the images. We have the circles surrounding the coins, then we have the number of coins, and then we are displaying the information through the console. So the way I see it, we have some small errors in the big the image with most coins, but it's okay. And also we have the centroids. Okay, so I guess it's pretty much done. We are already detecting the coins in the images, and then we are building the centroids for each coins. And then we can see it here. It pretty much detects us for us most of the in the images with less coins, it detects all of them for us, but in the other image with a lot of coins, it has a small error till 10% of error, which is okay. And there you have, guys, we have successfully built a program to count the number of coins in an image using Python and OpenCV. I hope you find this tutorial informative and enjoyable. If you like this video and found it helpful, don't forget to give it a thumbs up and hit the subscribe button below for more content like this. If you have any questions, suggestions, or just want to share your thoughts, feel free to leave a comment down below. I will do my best to answer all of your queries and engage with your feedback. Thank you so much for watching, and I will see you in the next video.